So let's move towards the next question. Question number 2: what is meant by the limit point of a sequence? And so that 0 and 2 are the limit points of the sequence defined by un equal to 1 plus minus 1 to the power n. So first we need to understand that limit and limit point are two different things. They are different from each other. A sequence may have two or more than two limit points. It may also have one limit point, but a sequence always have only one limit. So what is a limit point? Limit point, let's assume L belongs to R is a limit point of the sequence consider un if either it repeat itself in the sequence un infinite times, or it is a limit point of range set of un. So first we need to understand it. L belongs to R is a limit point of a sequence un. This L is a limit point. R means real number. L belongs to R is a limit point of sequence un if either it is repeated in the sequence infinite times or it is a limit point of the range of set un. Let's take example. For example, given 0.9, 0.99, 0.999, 0.9999 tends to infinity. So it is moving towards 1. So limit point of this sequence would be 1. Let's take another example. 0, 1, 0, 1, 0, 1, 0, 1, that's to infinity times. So the value 0 and 1 are repeating infinity times. So the sequence have two limit points, that is 0 and 1. It have two limit points, but limit always have only one value. So this is limit points is different from limit. So given question is un equal to 1 plus minus 1 to the power n. So we're gonna solve it. Let's take 1. First term is 1 minus 1 minus 1, 1 minus 1 0, and second term here we take 2. 2 means odd. 1 minus 1 to power minus 1 to the power 2 is positive 1. Positive 1 1 2, and my third term n equal to 3, minus 1 1 minus 1 0, and 2 0 2. It is gonna repeat infinity times. So this is just as example as second example. So 0, since 0 and 2 are repeated infinite in the given sequence un, and so 0 and 2 are the limit points of sequence defined by un 1 plus minus 1 to the power n. So let's move to next question. Question number 3: state the criteria for a series summation un to be convergent. So it is asking for a criteria of a series un to be convergent. So we know a series summation un is said to be convergent if sequence of its nth partial sum Sn is convergent. It means, let's suppose summation un is infinite series. Let's suppose summation un is an infinite series. So let's take a point n. Let's take nth point. That could be any point of infinite series. Means Sn is equal to plus to un. Then Sn is called sequence of nth partial sum of summation un. So if we prove Sn is convergent, then this means summation un, which is infinite series, is also convergent. That means if we prove this Sn, we just assume any point of infinite series and take a nth partial sum of summation un. If Sn is convergent, then infinite series summation un is also convergent. That's the criteria for series to be convergent. So let's move to next question. Summation un is given to the power n. So what is the first term of the summation un? 2. First term is 2, and second term 2 square plus 2 cube plus 2 power 4 plus this goes to infinity. So we can just see it from here that this is a geometric series. So first, here a common ratio is 2 and 2 and 2, and this goes to infinity. So we must know the rule of a geometric series test. So this geometric series has common ratio r equal to 2, which is greater than 1. We need to understand the rules of geometric series test. First, if ratio is less than 1, then it means it is convergent. If the common ratio is greater than 1, then this means it is divergent. Or common ratio is equal to 1, then it is also divergent. So 2 is greater than 1. 2 is greater than 1 means common ratio is greater than 1 means it is divergent. So since this geometric series has common ratio 2 which is less than 1, so it is divergent, or we can just write non-convergent, because the question has determined whether the series is convergent or non-convergent. So we can just write it divergent or non-convergent, this one.